Alrighty, in this video here, we're going to be talking about lesson 11.2, which is going to be matrix notation and Gauss-Jordan elimination. This is basically just another approach to solving system of all types, variable, three variables, and so on. Some glitching issues. Let me fix that real quick. There we go. All right, if you've never seen or heard of a matrix, let me just kind of give you the brief overview of what this section talks about, and then we'll do some examples that would go over in your homework. For starters, we'll talk about matrices and matrix notations. All right, a matrix is made of elements. Keyword there for your vocabulary. It's pretty much set up like this. You usually have two brackets and then a whole bunch of numbers called elements. This right here, when you go this direction, if you're familiar with Excel, these are called rows. And these guys right here are called columns. And we represent each element as A, I, J, where I is a row, where I is a row, and J is a column. So if I wanted to know where A23 was, that just means I go to row 2, column 3, and that would be the element there. So again, for instance, if I wanted to know A32 or 23, I forgot what I said now, but regardless, all right. So basically what we're going to do here in today's lesson is we're going to learn how to convert equations to matrices and vice versa. The equations, though, must be in standard form. Some examples of that, if you were only dealing with two variables like x and y, you have ax plus by equals c. If you had three variables, then it'd be ax plus by equals cz equals d, and so on and so on. So basically, standard form, you have everything in order from x's all the way to whatever letters you end up having. I think in this book, it does go to 5, but I don't think it's going to affect. I mean, you're not going to see that more than 3 variables when at the solving, but you will eventually. If you ever take like linear algebra, which you typically take either with or right after calculus 2. What we do is we call these augmented matrices when you go from equations to matrices. An augmented matrix would simply just be, this would be your x1, y1 values. This would be your x2, y2 values. And then this would be like what they're equal to. This little line here just represents the equal to sign. Now, once it's in this, we have a few ways on how to solve this. We have what we call row echelon form. And basically what that does, it forms a diagonal of ones. And then you have a triangle. Well, this is pretty bad off. Let's try to do that again. So one here, 0, 0, 0, 0, 0. So you have like a triangle of ones, and then you do have some like random numbers. That's it. They're not random. They kind of go with the equation. And then you would have some other numbers over here. And what this does is basically, if this is your X, Y, Z, W, or whatever the situation might be, and you could have just 2 or 3, and you'll see some different cases. But what you basically did is you now know what the variable of this is. Let's say this was W. W would equal this number. So then you would back substitute into this equation, solve for Z. Once you have Z and W, you back substitute, solve for Y. Once you have Y, Z, W, back substitute in and solve for all those, and keep going that direction. Sometimes you can just have 2 variables you're doing that with, sometimes 3, sometimes 4, and sometimes potentially even more. We do have rules to get it in this form, and these are called row operation rules. First rule being rows can interchange. So as I produce my augmented matrix and I see that I already have some zeros, they're just in the wrong spot, like in the location, I can switch the rows, and then now I can have those zeros in the right locations or ones or whatever you might be dealing with to get it in this form. I can just switch rows to do that. And I'll show you some concepts of that. You can multiply any row by any number that's not 0. So you can multiply any row by any number. We'll be specific here, by any real number. You can technically multiply by 0. You just wouldn't produce anything. It would just eliminate everything, and then you'd be stuck. And the last rule is you can add any rows together to make a new row. So you can add any rows together to make a new row. What I mean by that is maybe I want to add row 2 to row 3 to make a new row 3 that would start producing the zeros or the ones or whatever the concept I'm trying to do in that situation. Now, this is again row echelon form, also known, I believe, as there it is, also known as the Gaussian elimination. And the reason it's called this is just like when we did addition elimination in the last video, we added rows together to eliminate variables. You're kind of doing the same concept. You're still adding equations together to eliminate a variable so that you can get it down to one single variable. There is one other way, and this is what we call the reduced row echelon form. And what you do here is you're actually producing, again, a diagonal of ones. But this time you're producing a triangle of zeros on both sides. And then you would be left with what each variable is. So X would equal, or Z would equal C, Y would equal B, X would equal A. So I wouldn't have to back substitute in. I would do it all. And this is actually another name for it, is called Gauss-Jordan elimination. And I'm going to be honest with you. I actually like Gaussian elimination better because once I get down to one variable, I just like to just back substitute. I feel like that's a lot quicker than still trying to manipulate these rows to then produce these zeros. But both ways have their benefits as well, depending on what you're kind of dealing with. And that's pretty much everything that's inside section 11.2. So what I like to do next is actually go ahead and do some examples that you would see on your homework. Let's first start off with number 3. It said, let C equal this big old matrix. So we got 1, 0, 5, -3, 2, 9, pi, e, 10, and -7. And you're asked to determine the following. So the first part is asking for the order. So the order of C is basically asking what are the rows by what is the columns. Basically, what size is this matrix? So remember, rows go this way. So there's 1, 2, 3, 4, 5 rows, and then 1, 2 columns. So the order of this matrix is a 5 by 2. All right. So that's what that first type of question is. The second type of question just simply says, what's the value at C23? So remember, this is C row column. So this means I need to go to row 2, column 3, but you'll notice there is nothing there. So this would actually be considered what they say, none, no solution, things like that. So C23 on this matrix does not exist. Part C then says, all right, well, what's the value of C51? So again, that's row, that's your column. So I'm going to go to the 5th row, first column, and I can see that my answer is 10. So the first couple of questions are basically just asking, do you understand how to name, how do you find elements, how do you make a matrix and things like that. But let's do another one to make sure you understand all the parts of a matrix. Let's look at number 4. This one says D equals -8, 0, 0, 13, 6, -9, -1, 3, 0. Hopefully I wrote all those right. Didn't write any extra numbers. Okay. Part A, again, what's the order? So the order of D, remember that's row by column. So that's 1, 2, 3 rows by 1, 2, 3 columns. So this is what we call a 3 by 3 matrix. It's also known as a square matrix. You're then asked to find, well, what's D23? So that's going to be row 2, column 3. So that's going to be number 3. Again, just so you know, if you don't understand that this is row by column and you go column then row, you will end up in a different spot, which is the incorrect answer. So do make sure you go row, then column to find your answer. Part C then says find the value at D33. So that's going to be row 3, column 3, and we see that that value is 0. So hopefully that makes perfect sense on where to find the elements, how to name the matrix. So then in the next type of question you'll have is you'll simply just be asked to write a matrix. You won't have to solve it at first, but you will have to ask to write it. So let's look at number 12. And you are given these 3 equations. 5x plus y minus z over 2 equals 3. And then 7z minus x plus y minus 2 equals 0. And then you have x minus 4 minus z, oh, these are in parentheses, equals y. All right, before you can just start plugging in numbers into a matrix, remember it has to be in standard form. So let's work these out. So when I look at this one here, notice I'm dividing both of these variables by 2. So what I can do is I can say this is 5x plus 1/2 y minus 1/2 z equals 3. Notice I'm still dividing each variable by 2, but now I have separated them. And remember, the standard form for 3 variables is ax plus by plus cz equals 3. Now, if you remember in algebra, we had what we call standard form where a couldn't be like a fraction or a decimal or a negative or whatever the concept might be. That's not the concept here. The standard form we're really trying to look for is to make sure you have the x term, then the y term, then the z term, and then the constant. All right, so if we look at this next one right here, this will give me, and again, I want to put it in this order. So I'm going to put the x term first. So that's going to give me a negative 7x. Then I want to do my y term next. So that's going to give me a plus y. Then I'll do my z term next. So that's going to give me a plus 7z. And then notice this constant here doesn't have a letter, so I must move it over. So if it's a minus 2, it now becomes a positive 2. Now I've put it in the correct order. Same concept here. I start with my x. And then I need to technically distribute a -1, but the y is on the wrong side. So I do want to move the y over. So if this is a positive y, this will now become a negative y. And if I take a -1 times a negative z, that will produce a positive z. Now watch what's going to happen here. A -1 times a positive 4 does produce a -4, but since there's no letter attached, it also needs to be moved over to the other side. But now that it's a -4, it will now produce a positive 4. Once you have it in the correct order, and you might have to do this in a couple of steps, which is perfectly fine, to write this out as a augmented matrix, you're going to write all the coefficients of your x's. So this would be a 5, a -7, and if there's no number there, there's an imaginary 1. So you would write a 1 to represent that there is one x. And then you would do your y's next. So in this case, that would be 1/2. I think you can type it as a decimal as well in the homework, just in case you're more comfortable with that. And then this would be a positive 1 and a -1. Again, there are imaginary 1s there. Then you do the z, so this is now -1/2. Again, notice that the signs of the numbers go with the numbers. So it's not just an operation. This is a -1/2. And this is then a positive z, and then a 1z. Then you're going to do this little bar here. That is your equal bar. And then you're going to write out what they're equal to. So 3, 2, 4. So at the beginning of the homework, all you have to do is build it. And then throughout the homework, you actually start working on solving them. All right. So let's work on the next type of problem you'll deal with. Let's look at number 26. All right, number 26, it says simply fill in the blanks by performing the indicated row operations. So in this one, they just tell you what to do. So you don't got to guess what to do. So again, they kind of slowly get you into solving these guys. So this is the augmented matrix you're given. And then they tell you that this will be -3 row 2 plus row, sorry, just looking at the book, plus row 1. And then it wants to know what would the new matrix be. Interesting. Normally, what we would do here is you would say which row you would put the new row at. It does not. I think what they're going to assume is whatever the last row is where you're going to add. But typically, what most, especially when you do take linear algebra, and this is what you're hyper-focused on, you would say equals row 1, basically stating, all right, you're going to do this operation, and then now you're going to replace row 1. So it didn't have that. I think the assumption is whatever the last row is the row that you will replace. As I look at the rest of them, that looks like to be the case. All right, so here we go. So with that said, I'm actually just going to rewrite row 2 because I know that that's not going to change. All right, now with that, I'm going to do the work one element at a time. So that means I do -3 times row 2 plus row 1. So that means -3 times 1, which is -3, plus 3, which would then give me 0. So again, you would take each element at a time. So -3 times the 1, which gives you -3, plus 3, which will give you, so let me write it out for you, just in case you're having a struggle seeing this. So this would be, again, -3, row 2, so this is going to be 1, plus row 1, which is 3. That's how I got 0 here. All right, now to do the second element, you're going to do the same thing, but now with the second element. So this is now -3 times 3 plus 2. So that's -3 times 3, which is -9, plus 2, which gives me -7. And then do the same thing to the last number, the last element there. So it's going to be -3 times 5 plus -7. So that gives me -15 plus -7 gives me -22. All right, and then that's your answer. It's not asking you to put it all the way down in row echelon form or anything. It just wants you to perform the indicated operation. All right, let me do another one with a little bit more going on. So let's look at number 40. Number 40 gives you 1, 3, -5, 3, -1, 0, -2, 8, 2, and then 4, 2, 7. Then this will be, it wants you to do two things. So it wants you to do -3, row 1 plus row 2. And again, what we're assuming is we are replacing whatever the last row is. All right. And then it also wants you to do this, and I'll do it in a different color so when we get to that work, we can see it better. We want to do 5 times row 1 plus row 3, and we want to equal that to row 3. Now, this part's not there, but we're assuming whatever this second one is, that's what we're replacing. All right, so what that does is that means that row 1 is not changing. I'm just gonna rewrite row 1 just so I already have it. So that's good. So now I'm gonna work on row 2. So again, for row 2, using that color, so that would be -3 times 1 plus 3. All right, so -3 times 1 is -3 plus 3 gives me 0. All right, then we move on to the next one. Again, talking about row 1 and 2. So this will be -3 times 3. That's what row 1 is. Plus -1, because that's what row 2 is. So -3 times 3 is -9. Plus -1 gives me -10. Now I'm going to do -3 times -2. So again, that's what row 1 is. Plus 8. So -3 times -2 is a positive 6. 6 plus 8 gives me 14. All right. And then I got to do the last one. So this is now going to be -3 times 4, because that's what row 1 is, plus 2. -3 times 4 is -12, plus 2 gives me -10. All right, now let's do the last one. So this would now be 5 times row 1, which is 1, plus row 3. So that's going to be negative 5. 5 times 1 is 5, plus negative 5 gives me 0. Notice I'm doing 2 operations in one matrix, and you can do that. You can do that as many times within one matrix, and then if I wanted to, I could keep this going, which you would if you had to keep going with it. All right, the next one now is 5 times row 1, which is 3, plus row 3, which is 0. So 5 times 3 is 15. 15 plus 0 is 15. Then we go on to the next one. 5 times row 1, which is negative 2, plus row 3, which is 2. So 5 times negative 2 is negative 10. Negative 10 plus 2 gives you negative 8. All right, and then we'll do the last one. So 5 times 4 plus row 3, which will be 7. So 5 times 4 is 20. 20 plus 7 is 27. And there you go. So you did both operations just as it was asked. And it didn't tell you to go any further. That's what's going to start you by doing. Once you understand that concept, now we can move on to the next concept, which is get this in row echelon form, which is also known as Gaussian elimination. So let's do a couple of those. So let's first look at number 52. This is 2x minus 4y equals negative 6. And this is 3x minus y equals negative 4. And you're asked to solve this. So step 1, put this in an augmented matrix. So here we go. So this is going to be 2, 3, negative 4, negative 1, and then negative 6, negative 4. So the beauty of matrices, it basically gets rid of the variables and just lets you basically multiply and add what you need to do. All right, here is the order that I like to do things. First thing is I work on this guy right here. I work on that guy to make it a 1. By doing that, I'm simply going to just divide that row by this number. So I'm going to do row 1 divided by 2, and that's going to be my new row 1. All right, so that's my first step to get that into a 1. So 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. Negative 6 divided by 2 is negative 3. And then I'm just going to rewrite this guy. Actually, let's do 2 things at once like the other one did. Make life a little bit quicker for us. So then the next thing, once that becomes a 1, is I want this to become a 0. So I have to use this one if I want to put it on the same step. So what I'm going to do is I want to say, all right, what can I multiply to row 1? So when I add it to row, you know what? It's going to, for the process that I do, it'd be a lot quicker to do it this way. So let's just keep with what we were doing. We'll say 3, negative 1, negative 4. All right, so now let's switch. So I want to make this a 0. So what it does, it kind of avoids fractions. We don't really like fractions. So now with this new row 1, what can I multiply by it so that when I add it to this row, it makes it a 0? And it's super simple. This is going to be whatever this number is, but its opposite sign. So this is going to be negative 3 times row 1 plus row 2 will give me row 2. So what that means is I want to multiply this by negative 3, add it to this, and it should give me 0. That's my accomplishment. So my accomplishment, first one was to take this guy to a 1, then this guy to a 0. So here we go. So that's going to be negative 3 times 1, which is negative 3, plus 3, which is 0. It's what I wanted. So again, the first row is not going to change. And then I keep moving on. So negative 3 times negative 2 is a positive 6. Positive 6 plus negative 1 gives me a positive 5. And I keep going on. Negative 3 times negative 3 is a positive 9. A positive 9 plus a negative 4 gives me a positive 5. Again, if you have to do some scratch work around it, by all means do that. The last step here for a 2 by 3 matrix, so it's 3 steps. Make this a 1, make this a 0, make this a 1. So for a 2 by 3, 3 steps. The bigger the matrix, the more steps there are. So for this one, I'm going to write it right here. I want to, again, make this a 1. So I'm going to take my row 2, and I'm going to divide it by that number. So in this case, I'm going to divide it by 5 to get my new row 2. So notice my first row still will not have changed. Okay, and really, once it becomes a 1, that row is pretty much done. And then now I'm going to work the rest. So 0 divided by 5 is 0. And you might be asking, I thought you could only multiply. Technically, I'm multiplying by 1/5 here. So when I say dividing, I'm really multiplying by 1/5. So I am staying within the rules. So 5 divided by 5 gives me 1. And then 5 divided by 5 gives me 1. You now have this in what they call Gaussian elimination. You have a diagonal of 1s and technically a triangle of 0s. So now we go and we back substitute in. Now remember, when we work this out, this was my x, this was my y. So when I want to write this back out as an equation, I'm basically stating, hey, y equals 1. And when y equals 1, I can back substitute in here. So this means I have 1x minus 2 times 1. So instead of -2 times y, I now know y is equal to 1 equals -3. So when I solve this, I get x minus 2 equals -3. So I'll add 2 to both sides. So x would equal -1. Therefore, my answer here is -1 comma 1 using the Gaussian elimination. All right. So let's do another one. Make sure you grasp that. So let's look at number 53. So this is going to be 2x minus 5y equals 11. 3x plus 2y equals 7. All right, so step 1, turn this into an augmented matrix. 2, 3, -5, 2, 11, 7. Again, now we didn't fall into that situation, but do make sure it's in the correct standard form. All my x's here, then my y's, and whatever other letters I might have. All right, so remember, step 1, turn this into a 1. Now, this is going to cause us to have fractions, but that's just where we're at. So again, I'm going to do row 1 divided by 2 gives me my new row 1. So 2 divided by 2 is 1. -5 divided by 2 is -5 halves. And 11 divided by 2 is 11 halves. And I didn't do anything with this one. All right, my next step. In FY, this is the process that I use because I find it to be the most structured. But you might start looking at this going, well, if I switch this row or add this row to this row, I could potentially get a 1 that way. By all means, go about doing that. Like you might look at this and go, well, if I just make this row 2 minus row 1, that would give me 1 as well. And that will. And that would keep you away from fractions as well. And that's perfectly fine by me. You just kind of have to look at it. But for me, the structure that I've done every time is to get them to 1s by dividing and doing this process. Doing it that way, that means you understand the process. So that's totally good with me. All right, but regardless, we're going to do this one next. We're going to turn this guy into a 0. So to do that, I'm going to multiply row 1 by the opposite of row 2. So that's going to be -3 times row 1 plus row 2, and that's going to give me row 2. Okay, so the first row is not going to change. And then now what I'm going to do is I'm going to go, all right, this is going to be -3 times 1, which is -3 plus 3 gives me 0. That's what I wanted. And then if you're good with fractions, you just do -3 times -5 halves, and that's going to give you 15 over 2. So again, this is -3 times -5 halves, which is going to be 15 over 2 plus 2. All right, so this is the same thing as 4 over 2. So that gives me 19 over 2. All right, and then I move on to the next one. So I'll go -3 times 11 over 2, which gives me -33 over 2 plus 7 over, oh, my bad, just plus 7. But that's the same thing as 14 over 2. So -33 plus 14, what is that, 9? No, that'd be 19 over 2. Let me just make sure and pull out a handy dandy calculator. 33 minus, yeah, 19. Okay. Can never be too sure. So that gives you a -19 over 2. So here we go. Again, if you're comfortable with fractions, this is the process that I like to do. If you want to try to make it so that you don't deal with fractions, perfectly fine with that. But every time I try to do that, I always get students go, when I tried that on the other one, it didn't work. Well, that process only worked for that situation. This process works for every situation. All right, so again, last step, make this a 9. Not bad. Make it a 1. All right, so when dealing with a fraction, instead of dividing by 19 halves, I could just multiply by its reciprocal. So that's what I'm going to do to get my new row 2. I don't know why I made that arrow so long. But I'm going to take row 2, and I'm just going to multiply it by 2/19. So this gives me 1, -5 halves, 11 halves. 2/19 times 0 gives me 0. So it doesn't have to change it. 2/19 times 19 over 2 gives you 1. And just an FYI, if you did not know that, 2/19 times 19 over 2, the 19s would cancel, the 2's would cancel, meaning you're left with 1. And then I do the same thing, and I do 2/19 times -19 over 2, I get a -1. So again, this is what it looks like. So the 19s would cancel, the 2's would cancel, and I'll be left with that negative, and then everything goes down to 1. All right, so now that I have it in this way, I now know that y is equal to -1s, because remember, this is my x, this is my y. So if y is equal to -1, this means that this is x minus 5 over 2 times -1. So instead of it being a y, I know what y is, equals 11 over 2. So here we go. So that gives me x plus 5 over 2 equals 11 over 2. Subtract 5 halves on each side. 11 minus 5 gives me 6 over 2, which does simplify down to 3. So therefore, my answer is 3, -1. All right. So again, the process I like does involve fractions. Hopefully you're good at fractions at this point. But if you're not, think of another way to make this a 1. And then that will avoid fractions throughout the rest of the process. So again, an easy way to do here is an alternative to avoid fractions. You could just say row 2 minus row 1 gives you new row 1. So that means 3 minus 2 gives me 1, which is what you're trying to accomplish. What the other numbers turn into, you really don't care. The only thing you care about is getting this diagonal of 1s and that triangle of 0s there. The only reason, again, I don't show this route is because this route doesn't always work. Sometimes you got to multiply these numbers, both rows, to be able to add them so that they equal 1. But if you see that, go for it. This process always works. It's the exact same thing I did on this side as well. It just happened to be nice, clean numbers throughout the process. All right. So now let's talk about Gauss-Jordan elimination, which is also known as row reduced echelon form. Same process. The only thing is we're also going to try to produce that triangle of zeros on the top of our matrix. So let's look at number 70. We'll do a few of these, and then that would be it. So here we go. So this will give me 2x minus 3y equals 8. 8x plus 5y equals -2. Again, to use Gauss-Jordan elimination, Same process. It needs to be in standard form so that you can write it as an augmented matrix. So this will be 2, 8, -3, 5, 8, -2. Process is pretty much similar as the Gaussian elimination. My first order of business is to turn this guy into a 1. So the way I'm going to do that, just like I've been doing, row 1 divided by 2 gives me row 1. So that's going to be 1. -3 divided by 2 is -3 halves. 8 divided by 2 is 4. This row stayed the same. All right, next process, turn this into a 0. So I'm going to multiply row 1 by the opposite of this guy. So that's going to be -8 times row 1 plus row 2 gives me row 2. First row is not going to change. All right, so -8 times 1 is -8 plus 8 gives me 0. That's what I wanted. Now this one, again, might have to do a little work here, but -8. Ooh, let me do the work underneath this one, just because we're going to need more work space. So that's -8 times -3 halves. Done lost myself. Row 1 plus row 2 plus 5. Okay, so -8 times -3 halves. 2 goes into 8 4 times, so -3 times -3. So -4 times -3 is +12. +12 plus 5 is 17. Then we'll do the same thing. -8 times 4 minus 2. -8 times 4 is -32. I don't know why I just stumbled on that one. So -32 minus 2 is -34. All right, so nothing again. Process has not changed. Next time, process, turn this into a 1. So this time I'm going to do row 2, divide it by 17 to give me a new row 2. So that's going to be 0. 17 divided by 17 is 1. -34 divided by 17 is -2. First row hasn't changed. All right, now this is where it gets a little different. Now I got to turn this guy into a 0. So just like I turned this guy into a 0, I'm going to kind of do the same process. I'm going to multiply this guy by this guy, but it's opposite. So I'm going to multiply row 2 by +3 halves. So 3 halves times row 2 plus row 1 to give me a new row 1. So the second row will not change. And then now, by doing that, 3 halves times 0 is 0 plus 1 is 1. So that's why we're doing it in this order, to avoid undoing anything we've already done. All right, so now this is 3 halves times 1. 3 halves plus -3 halves is 0, which is what you wanted. And then 3 halves, so again, if you don't see this with fractions, 3 halves times -2, the 2's would cancel, so you'd be left with a -3 plus row 1, which is +4. So -3 plus 4 is 1. So the nice thing about Gauss-Jordan elimination, or row reduced echelon form, is now I can say, all right, well, x equals 1, y equals -2, and I'm done. I don't have to back substitute. I instantly have my answers. All right. Let's do another one, but a little bit bigger. So let's look at number 81. So number 81 is -5x plus 9y plus 3z equals 1. Then this is 3x plus 2y minus 6z equals 9. And then this is x plus 4y minus z equals 16. So remember, the first step, always the same. We just have more of them. So turn this into an augmented matrix. Make sure it's in the correct order. So this will be -5. Make sure I wrote that all correct. All right. So this is -5, 3, 1, 9, 2, 4. 3, -6, -1, and then 1, 9, 16. All right, because it's asking us to use the Gauss-Jordan elimination, that means we have to make this a 1, 0, 0, 0, 1, 1, 0, 0, 0. So I'm going to go in this order. Actually, I think I go 1, 0, 0. Then I turn this into a 1, then 0, then 1, then 0, and so on. But I don't think it really matters as long as we kind of stick around this. All right, so first step, turn this into a 0. So, or sorry, turn it into a 1. So that means, and it doesn't matter which row you use. I think I'm going to use this row since it's already a 1. Oh, I see. Okay, so yes, you can deal with fractions. But I think I'm going to try to show you some tricks on this one so that we can avoid some fractions. So typically, I would divide this by -5, divide this by -5, and this divided by -5, and then we're dealing with fifths. Completely logical way to do this, but I want to do this using some number sense. So the goal is to make this a 1. So what I'm gonna do is I'm actually gonna multiply this guy by a number so that when I add it to this guy, it gives me a 1. So I'm gonna do 6 times row 3 plus row 1. And when I do that, 6 times 1 is 6 plus -5 gives me 1. So here's a number sense process. So when I do that, I'm sorry, this is going to be a new row 1. So that's going to give me 6 times 1, which is 6, plus -5 gives me 1. 6 times 4 is 24. 24 plus 9 is 33. 6 times -1 is -6. -6 plus 3 is -3. So -6 plus 3 is -3. 6 times 16. All right, so that's going to be 60, 96. This is 96 plus 1, so that's 97. Okay. All right, I also want to produce this as a 0, and again, I'm going to use row 3 to do that. So in this case, in this next step, I'm going to go ahead and move on to this one because I can. I have that ability, where the other one, I really didn't until I had the new matrix. So on this one, I'm going to multiply this by some number. So when I add it to this, it produces a 0. So that's going to be a -3 times row 3 plus row 2 gives me row 2. So here we go. So -3 times 1 is -3 plus +3 gives me 0. -3 times 4 is -12. -12 plus 2 is -10. -3 times -1 gives me a +3. +3 plus -6 gives me a -3. And then we have -3 times 16. It's not going to be, it's going to be -30, -48. So -48 plus 9 gives me -37. All right, I'm just going to check my math real there. So 16 times 3 is 48. And then that was negative, so then we subtract 9. Oh, we get 39. Okay, glad I checked it. Because again, that's going to be a -48 plus 9, so that's going to be a -39. All right. The next move I would want to do is make this a 0, but I need these guys to do it. So I'm actually just going to rewrite the bottom row as is and do 2 steps again. This time I want to make this guy a 0. And to do that, I need to multiply something so that I can add it to this. And I think the easiest way to do that is multiply row 1 by a negative and then add it to row 3. You could have also simply just said row 3 minus row 1. I'm good with that too, same process. That's going to be my new row 3. So let me get my new row 3 going. So that's going to be a -1 plus a 1, which is a 0. That's a -33 plus 4 gives you -29. That's going to be a 3 plus -1. That's going to give you a 2. That's a 3 plus -1. Yep. That's going to be a -97 plus 16. So 97, let's make it a negative, plus 16, we get a -81. All right, in the same process, I do want to make this guy a 1 so that on the next step, I can turn this one into a 0. So that's what I'm going to do as well. Again, trying to do multiple steps here. So again, I'm going to make this guy into a 1. And looking at it, dividing it by -10, is this going to give me fractions again? Let's see if we can avoid that. I don't want to deal, I might have to deal with fractions here. Because I don't want to eliminate this 0 that I've already worked hard for. Yep, so that's what I'm going to do. I'm going to do row 2 divided by -10 to give me a new row 2. I don't see an easier route there. Y'all might be yelling at the screen going, well, if you just multiply this and add that and you'll get it. But make sure whatever process you do doesn't change that from a 0. So maybe you might want to wait until the next step and do it to this one, right? And that might be the process to do. Like if I multiply that by 3, yep, I think that's the route I'm going to go. Here we go. So that's what I'm going to do. I'm going to wait until the next step. So 0, -10, -3, -39, 1, 33, -3, and 97. Trying to avoid big fractions here. All right, so the first thing I'm going to do is I'm going to work on that row 2 first to make that into a 1. So if I multiply row 2 by a -3, that will give me a +30. And then if I add it to row 3, that will give me 1. So that's what I'm going to do. So the first row, not changing. Second row, again, that's going to be -3 times 0 plus 0 stays 0. That was the goal. -3 times -10 is +30. +30 plus -29 gives you 1. -3 times -3 is +9. +9 plus 2 gives you 11. Okay, let's do a little handy dandy calculator again here. Make sure I don't make any mistakes because that's what can happen in this stuff. So that's going to be a -3 times a -39 gives you a +117. And then we're going to subtract basically 81. So that gives you a +36. All right, so now that I've gotten this part to a 1, the next goal is to make that a 0, but I need this row to do it. So I'm just going to rewrite this now. All right, I don't think I've changed colors in a while. So again, the goal now is to turn this into a 0. And by doing that, let's see, so that's going to be, if I multiply this row, because again, I don't want to change these zeros. So I'm going to do 29 times row 2 plus row 3 to get my new row 3. By doing that, watch what happens. So I'm going to do 29 times 0, which is 0, plus 0 gives me 0. Good. Did not want to change that. This is now going to be 29 times 1, which is a +29, plus a -29, which will give me 0. Great. That was my accomplishment there. So now dealing with a little bit of big numbers here. A little bit. So this will be 29 times 11 gives me 319. Plus 2 gives me 321. So this is 321. And then now I want to do 29 times 36 gives me 1,044 minus 81. So that gives me 963. All right, in the same process, I do want to make this a 0, but for that to be a 0, I need this to be a 1. So that's going to have to be my next step. So I'm going to have to rewrite all these. All right. So again, I'm just going to take row 3 divided by 321 to produce my new row 3. So again, that's going to be 0, 0, 321 divided by 321 is 1. Bet this comes out clean. 963 divided by 321 comes out 3. And then now that that's a 1, I can then use that to produce this into a 0, but I need it for the next step. So I'm going to have to rewrite this. 0, 1, 11, 36, 1, 33, negative 3, 97. Don't know what just happened to those numbers. Negative 3, 97. All right, here we go. Definitely needed more room. All right, so I now got this a 1. The goal now, and I haven't switched colors in a while, so let's switch. I want this to be a 0. Again, if this was Gaussian elimination, I could be done here and do a bunch of back substitution, but it wanted us to use Gauss-Jordan elimination. All right, so I'm going to produce this as a 0, and the best way to do that is to do row 3 times negative 11 and add it to row 2. So that's what I'm going to do. So my last row there is good to go. Like I don't need to do anything to that anymore. And then when I do the work, so negative 11 times 0 plus 0 keeps the 0 that I want. Negative 11 times 0 plus 1 gives me 1, so it hasn't changed anything. Negative 11 times 1 is negative 11, plus 11 gives me 0. I got what I wanted. Now I got to do negative 11 times 3, which is negative 33, plus 36, so that's going to give me 3. Are you serious? Are they both the same answer? Oh. All right. Okay. All right. Now the next move is I got to make these both a 0, and I can do that at the same time using both of these equations. So I'm going to do that in the next step. So 133, negative 3, 90. Actually, I'm going to need to do them separate. They can do them at the same time. So let's do another one here. So if I got this one already, what would be easier to turn? I'm going to turn this guy into a 0, mainly because I already have this at what I want it. So I'm going to do 3. I know this is going to be hard to see, so definitely pay attention. So it's going to be 3 times row 3 plus row 1 gives me a new row 1. So again, I'm going to read that again. That's 3 times row 3 plus row 1 equals row 1. So what I'm going to do is I'm going to do 3 times 0, which is 0, plus 1, which is 1. 3 times 0, which is 0, plus 33 is 33. I'll have to change that one as my last step because I couldn't do it because I finally got that where I needed to be. And then I'm going to do 3 times 1, which is 3, plus negative 3 gives me 0. And then 3 times 3 is 9. 9 plus 97 is 106. So again, 9 plus 97, 106. All right, so here we go. Here's our last step. I need to make this guy a 0 using row 2. So I'm going to do negative 33 times row 2 plus row 1 to give me my new row 1. So here we go. So that bottom row good to go. Don't need to do anything with that one. Second row is now good to go. Don't need to do anything in that one. So this is going to be negative 33 times 0 plus 1 gives me 1. I did not want to change that. Negative 33 times 1 is negative 33, plus 33 is 0. That's what I wanted. Negative 33 times 0 plus 0 gives me 0. I did not want to change that one either. Now I can move on to this last step. I'm going to need a handy dandy calculator. So in this one, I'm going to do negative 33 times, where's row 2? Times 3. And then I'm going to add that to 106. And when I do that, I get 7. So therefore, my answer here would just be 733. So this is a new process that you can now use to solve for 3 variables. I do want to do one more because it does throw a, so I always thought in pre-calc, 3 variables, all you have to go. No, they do throw a 4 variable equation at you. So let's look at that one so we can learn some tricks to the trade, and then that will be the last one. So let's look at number 93. All right, 90. Ooh, I'm just going to write the equations. All right, 93 is given to you as W minus X plus 2Z equals 9. And then we have two W plus 3Y equals negative 1. Negative 2W minus 5Y minus Z equals 0. And then we have X plus 2Y equals negative 4. All right, so it looks like the order they have this is W, X, Y, Z. So to do that, I'm going to do this. So that's going to be W minus X. I don't have a Y. So for making sure we don't mess up, I'm actually going to put a plus 0Y plus 2Z equals 9. This will help me know that when I make my augmented matrix, it needs to have a 0 as a placeholder because it doesn't have any Y's. This will then be 2y, 2w plus 0x plus 3y plus 0z equals negative 1. Again, I'm writing these out as placeholders. This is now negative 2w plus 0x minus 5y minus z equals 0. And then this is going to be 0w plus x plus 2y plus 0z equals negative 4. Now, personally, this equation, I would definitely do elimination. I would just solve for one, substitute a lot of them in, but again, it's asking us to use Gauss-Jordan elimination. So that's what we're going to practice. There we go. We start with our augmented matrix. So that's a 1, 2, negative 2, 0, negative 1, 0, 0, 1. Then we have a 0, 3, negative 5, 2, 2, 0, negative 1, 0, 9, negative 1, 0, negative 4. All right, so we got to pay attention to what we want. We want a diagonal of 1s and a whole bunch of 0s. I see that this guy is a 1 on the second one, which is what I'm going to want. So I'm actually going to switch, and I do not remember the notation for switching. Let me just... Oh, there it is right there. Okay, so what we're going to do is we're going to switch. We haven't done this before, but I want to switch row 4 with row 2. Because it already has it in the form that I want. So I'm going to do 1, negative 1, 0, 2, 9, and then 0, 1, 2, 0, negative 4. Row 3 will stay the same. So negative 2, 0, negative 5, negative 1, 0. And then row 2 will now become row 4. So that's going to be 2, 0, 3, 0, negative 1. All right, so again, I did that because I know I want a diagonal of 1s here, and this already had it. So now my next goal is to make these guys a 0. And I think I can do this Let's see. So if I add, let's see. So we can do this in a couple ways. I can add this row to this row to make it 0. Yeah, I think that'll work. So I'm going to make this guy 0. I already have a whole bunch of zeros, so a lot of the process looks like it's kind of done for me. So it's not maybe not take as many steps, having so many variables involved. So I'm going to do row 4 plus row 3 and give me a new row 3. So when I do 2 plus -2, that gives me 0. 0 plus 0 is 0. 3 plus -5 is -2. 0 plus -1 is -1. And then -1 plus 0 is -1. So I'm going to just rewrite all this. All right, my next goal is to make this guy 0. Switch colors so we can see that. So I'm going to make this 0, and I'm going to use row 1 to help me. So I'm going to do -2 times row 1 plus row 2 to give me a, not row 2, row 4, to give me a new row 4. And again, I might be able to do a couple steps. So I'm just going to replace this one. So -2 times 1 gives me -2 plus 2 gives me 0. -2 times -1 is 2 plus 0 gives me 2. -2 times 0 is 0 plus 3 gives me 3. -2 times 2 is -4 plus 0 is -4. -2 times 9 is -18 plus -1 gives me -19. Next goal to make this a 0, and I'm going to need row 2 to do that. So I'm going to have to rewrite some of this. Key to this, try to stay as organized as you can. Try a different color. All right, so I'm going to do row, I'm going to do -2 because I want to make this a 0. -2 times row 2 plus row 4 to give me a new row 4. Again, I'm going to try to do some of this step at the same time. So it's going to be -2 times 0 plus 0. That's going to give me 0. That's good. I didn't want to change that. -2 times 1 is -2 plus 2 gives me 0. That's what I wanted to accomplish. -2 times 2 is -4 plus 3 gives me -1. -2 times 0 is 0 plus -4 gives me -4. -2 times -4 is 8. 8 plus -19 is -11. I want to make this a 1, so I'm actually going to deal with fractions because halves are definitely not that hard to deal with. So I'm actually also going to do row 3 divided by -2. So 0 divided by -2 is 0. 0 divided by -2 is, give me a new row 3. 0, -2 divided by -2 is 1. -1 divided by -2 is 1/2. And -1 divided by -2 is, again, 1/2. All right, so then I get 0, 1, 2, 0, -4, and then 1, -1, 0, 2, 9. All right, so my next move is to make this a 0. So I can see that because I did this step, I can actually go ahead and just say, all right, this is going to be row 3 plus row 4 gives me new row 4. All right, when I do that, that's going to be 0 plus 0, which is 0, 0 plus 0, which is 0, 1 plus -1, which is 0, 1/2 plus -3, 1/2 plus -4, that's going to be 8/2, so that's going to be -7/2. And then 1/2 plus -11, again, that's going to be -22, so that's going to be -21/2. And then this will all be good for right now. All right, so I now want to make this guy a 1. I'm going to switch colors. And we at least will then have it in, what's his name? Gaussian. Yeah, Gaussian elimination form. So this is now going to be row 4, and I'm going to multiply by its reciprocal. So that's going to be 2 over -7. Will give me my new row 4, and my row 4 will be done. So -2/7 times 0 is 0, 0 is 0. -2/7 times positive -7/2 does give me 1, because again, the sevens would cancel. And then when I do 2/7 times -21, let me just show you this math real quick. So that'd be 2 over -7 times -21 over 2. The 2's would cancel, but the 7 would go into 21 3 times. So that's really a positive 3. All right, now that I have it in this form, my goal is to make that a 0, but I need this form to do it. So let's just rewrite it. All right. Process, I don't think it's hard. I think it's just long. All right, so let's look at this in a different color. Let's go. All right, I want to make this guy a 0. So that's going to be row 4 times -1/2 plus row 3. Give me a new row 3. Maybe I can do some of these in the same steps. 0, 0, 0, 1, 3. And then, all right, so that's going to be a -1/2 times 0 is 0 plus 0. So these two won't change. And then -1/2 times 0 plus 1 will stay at 1, which is what I wanted. -1/2 times 1 is -1/2 plus 1/2 will give you 0, which is what I wanted. -1/2 times 3 is -3/2. -3/2 plus 1/2 is -2/2, which become -1. There you go. So there's -1 there. All right, I need to make this guy a 0, but I need this row to do it. But while I'm here, I could make this guy a 0 as well. So that's what I'm going to do. I'm going to do -2 times row 4 plus row 1 to give me row 1. All right, so I can't do anything to this one yet because I need this row now to add to that one. All right, so then, but I can't eliminate this guy. So that's going to be all 0, so that's not going to change these. So 1, -1, 0. -2 times 1 is -2, plus 2 is 0, which is what I wanted. -2 times 3 is -6. -6 plus 9 gives me 3. All right, so getting close. I'm almost done because I got to make this a 0 and make this a 0. To make this a 0, I need this equation. To make this a 0, I need the equation that this equation is going to produce. So I'll have to do 2 more steps and then I'll be done. Can't do it at the same time because I need this one to be a 0. The goal is when I multiply by this to add it, I don't want to change these zeros now that I've done the work. All right, so there we go. So this would be -2 times row 3 plus row 2 gives me row 2. So that's going to be, so first row or fourth row, already good to go. Basically, I know that z is equal to 3. I also know that y is equal to -1. And now we're about to determine what x is equal to. So -2 times 0 is going to be 0 plus this. So these two things will not change. This will produce a 0, which is what I wanted. -2 times 0 plus 0. So that's what I didn't want to change. So -2 times -1 is a positive 1 plus or positive 2. So -2 times -1 is positive 2 plus -4 gives me a -2. I now know what x is. And I want to get rid of that one, but now I need this equation to do that. So I'm going to have to rewrite that first row. And here's my last step. All right, so that's going to be basically just row 3 or row 2. Row 2 plus row 1 give me row 1. Again, last row, good to go. Second to last, or row 3, good to go. Row 2, now good to go. And then now this is going to be 0 plus 1, which is 1. 1 plus negative 1, which is 0. 0 plus 0 plus 0. There we go. And then last one, so the negative 2 plus 3 gives me 1. So my final answer, and I'll write it up here, is going to be 1, negative 2, negative 1, 3. And that's how you can use the Gauss-Jordan elimination. All right, so again, you'll see why you have so little homework questions, because this process can definitely take a process. But if you need more examples than that, please let me know. You've seen a process that will work all the time, and then you have seen a couple of processes now, just using number sense. You know your end goal. What can I do to manipulate this? When it comes to fractions, for me, halves and thirds and stuff like that aren't bad. I would have probably done fifths on that first one, but I want you to see some number sense as well. All right, if you, again, need any more examples, again, please reach out. See you in the next video.